Ladies and gentlemen, I am Panu Partanen, Vice President at Vaisala Corporation. I am responsible for our meteorology and aviation business. Vaisala is the leading supplier for weather measurement systems in the world. We are serving over 150 countries every year. We have the widest portfolio of weather measurement systems matching all the needs of meteorological services. We are very proud of our reputation of being a reliable supplier, being always there for our customers. On today, we are going to present a couple of new innovations by our experts. I am sure you will find them interesting. Please do not hesitate to contact us in case you want to learn more or have any questions. Thank you. Please enjoy.
The CL61 is the first of its kind LiDAR ceilometer that goes beyond standard cloud height reporting by leveraging depolarization technology. It provides more refined profiling data for deeper insights. The new depolarization measurement capabilities that until now have only been available in research LiDARs enable accurate liquid frozen differentiation, detection of dust, sand and volcanic ash layers, aerosol characterization, and the ability to make short-term forecasts of precipitation. The CL61 is built for non-stop operation in any location you place it. Unlike many other instruments, it provides constant data availability regardless of prevailing weather conditions. With functionality previously only available in the scientific research-grade LiDARs, CL61 is significantly more affordable to purchase, maintain and operate. We will bring new innovations for the users, with the unique features and technical innovations that will enable high-quality profiling for a huge amount of different applications. There is nothing in the market that comes close what CL61 is and what it does. The new CL61 is made for vertical atmospheric profiling and it brings new valuable information that the end user have been waiting for. Like other ceilometers, the CL61 also provides cloud height and attenuated backscatter profiles. We have enhanced the profile quality with new optical system, bringing best-in-class signal-to-noise ratio to reveal even more details from the atmosphere than before. The CL61 utilizes proven Vaisala single-lens technology, which enables reliable low-altitude detection. With new patented narrowband transmitter technology, we have eliminated water vapor absorption effects from the vertical profiles. And as a first in industry, we will provide traceable factory calibration. In addition to standard profiling, we have added the depolarization ratio profiles which enable differentiation of liquid and solid particles. It also provides information about the cloud phases like ice and supercooled clouds and allows tracking of volcanic ash and other solid particles. Planetary boundary layer profiling will be significantly enhanced with this depolarization information when, for example, melting layers can be identified with ease. With the depolarization measurement, it also has potential use in aerosol characterization. The CL61 is designed to fill in the gap between research instruments and ceilometers. Accurate forecasts require accurate observations. CL61 allows wide use of depolarization ratio profile data, providing added information for the users. This measurement has not practically been available until now. Unlike many other instruments, CL61 measures reliably in any weather conditions without interruptions. It is designed to be used in operational networks that unlocks new opportunities for collecting and using comprehensive datasets. This level of performance and ease of use has never been more affordable. Just like other Vaisala ceilometers, CL61 is virtually maintenance-free and does not use consumable parts, which typically reduces cost of ownership even further. It takes less than an hour to get the CL61 from box to operation and it fits into existing Vaisala ceilometer footprints. It supports commonly used NetCDF data format and comes with professional software security and Ethernet connectivity. Vaisala has been the pioneer in ceilometer development for decades. We take great pride in developing products that are accurate yet reliable, and that has applied to this ceilometer as well. So, get yours now and enhance your profiling capability to the next level.
Vaisala FD70 is an optical sensor which transmits a thin light sheet of infrared light and then measures how the light scatters in collisions with airborne particles such as fog, sand dust, and precipitation. Because of the light sheet transmitter, we can say the FD70 is a combination of a forward scatter sensor and an optical dysphometer. Thanks to this new unique measurement arrangement, the sensor is of reference-grade performance. According to WMO, the size threshold for reporting precipitation is 0.2 millimeters in diameter. However, the FD70 detects even much smaller droplets, everything down to diameter 0.1 millimeters, individually one by one. Thus, you can trust the FD70 never misses even the lightest precipitation events. Here, the FD70 is many instruments in one. Installation is easy. There is no need for on-site adaptation or calibration. Initiation is done using a computer and a standard Ethernet maintenance cable. Many in one, easy installation and weatherproof design make the FD70 the most cost-efficient solution in weather station networks. The FD70 is our 7th generation of present weather and visibility sensors. The sensor's innovative new technology bases on decades of scientific studies and product development, as well as feedback from a vast installed base. Shortly about challenges faced by present weather sensors. Firstly, before identifying precipitation, you need to be able to detect. The most common issue with conventional sensors is lack of sensitivity. The sensor reports nothing while human observer reports precipitation. Secondly, even with droplets detected, identification part can go wrong. Most of the sensors are forced to work with inadequate and noisy raw data that doesn't allow proper analysis. Depending on which reporting features are selected, the FD70 is delivered either with only one receiver or two receivers. For example, this new feature of enhanced freezing conditions reporting, it requires two receivers. In FD70, it all bases on single particle analysis. The FD70 is actually a particle scanner which analyzes every particle one by one using Vaisala proprietary algorithm for present weather reporting. Every precipitation particle of different shape or different state has its own type of light scattering properties. With our 5 MHz sampling combined with powerful modern signal processor, the sensor is able to analyze every individual droplet's scattering properties. In addition, the FD70 also has an integrated temperature and humidity sensor, Vaisala HMP 155. This high-performance probe provides the FD70 with air temperature and wet bulb temperature. The wet bulb is needed in identifying the most important and dangerous precipitation types, freezing drizzle and freezing rain. On the left, we illustrate agreement percentage in freezing rain, and on the right in freezing drizzle. This bases on 3-month dataset from last winter, early 2021. It shows us that FD70 and human observers reporting are very close to each other. FD70 is close to human, or actually, maybe we could say that the human is close to FD70. Thank you very much for watching.
So I'm going to talk about weather radar and why weather radar is a unique and good instrument for severe weather detection. Well, first of all, a weather radar can detect many different phenomena that are important in severe weather detection. So let's take an example of thunderstorms. So weather radar can detect the thunderstorm. It can measure the precipitation in the thunderstorm. It can measure the vertical structure of the storm, and it can also detect the winds inside the storm. The modern Doppler weather radars are able to also detect the winds. So you can make really good measurements regarding the structure of the storm. The weather radar data can also be used to provide a short-term nowcasting, so forecast for a couple of hours, typically say 2 hours forecast, and it's based on the latest measurements from the weather radar. Longer term forecasts typically require other type of information and forecasting models and data from soundings and other instruments as well. But for this kind of short-term forecasts, weather radar information alone can be used, and you can make a short-term forecast. And that's really good also, of course, for making warnings, alerts, and detecting different kinds of phenomena in severe weather monitoring. Then what Vaisala has to offer in the weather radar product area. We have different weather radar models for different purposes. And what is important when building a weather radar network? Of course, data availability is the key. So it doesn't matter how good your radar is if the radar is down when there's something dangerous happening. If thunderstorm is approaching and your radar is down, it doesn't help if you are not able to use it. So data availability is really a key, and that means that your instrument's reliability needs to be really good. And then the data quality as well. If your resolution is not good enough and the data quality overall is not good enough, that leads to poor detection rates and possibly also false alarms. So data quality is a key as well. So you need to have continuous data 24/7 without any interruptions, and the data quality needs to be good enough that you don't make false alarms and you are able to detect the phenomena that you are interested in. And what in Vaisala's weather radar systems makes them unique and improves these two things, quality and availability. We have implemented the radars using an architecture where we have placed the electronics of the radar behind the antenna. So this way we can build the radar to be really compact, and we can simplify many things in the radar. For example, the signal path from the antenna to the receiver and from the transmitter to the antenna is as short as it can be. That simplifies the signal path, shortens it, which means that the data quality is better. It improves the rainfall rate estimations and the range of the radar and capability to detect weak signals. So overall, the Vaisala weather radar systems are built for reliable operation and to provide high quality data. That is, both of those are the most important factors when building a severe weather monitoring system.
Soundings are, also according to the World Meteorological Organization, WMO, one of the most important ways of getting accurate atmospheric data. This data is used, for example, to create accurate weather forecasts or predicting possible severe weather phenomena. Performing soundings is necessary, and it can be done efficiently with automation. Automated soundings provide this efficiency in forms of consistency of the data, personal safety and ergonomy, and operational cost savings. Vaisala's automatic sounding station, AutoSound AS41, is the most advanced automated sounding system on the market. AS41 is the latest generation of Vaisala's AutoSounds that follows the previous model AS15. The AS41 is a totally new design of all the previous AutoSound models, keeping only the best features of its predecessors. One of these features is the fully separated operator space and launcher vessel, from which the meteorological balloon together with the radio sound are released. This allows the gas piping to never enter the operator space and makes the AutoSound a safe place to work. It is simply impossible for any gas to leak inside the AutoSound. The AutoSound AS41 is capable of utilizing either helium or hydrogen as the lifting gas for the balloon. The user can actually change the used gas with just one setting in the AutoSound control software. No hardware changes are needed, as the AS41 fulfills hazardous area-related EX regulations with the standard components. As hydrogen is a cheaper gas than helium, the option to utilize hydrogen provides operational cost savings. User safety is taken into consideration also in other features of the AutoSound. The moving mechanical parts are isolated to prevent the user accidentally getting hurt when the AutoSound is operating. The maintenance of the unit is made simple and safe, as all parts and components are easily accessible, and the maintenance platforms outside of the unit help reach necessary components while providing a safe base for working. The AS41 can be loaded with up to 60 radio sounds and balloons. The high capacity enables autonomous operation of up to 30 days, assuming 2 soundings per day. During this time, there is no need for an operator to visit the AutoSound. Loading sequence is made easy, and with the help of the patented load assistant tool, it takes less than 3 minutes to load one tray with a sound and a balloon. During these 3 minutes, the system also makes an initial check for the radio sound to ensure that all the loaded sounds are operational. All 60 trays can be loaded with just a half day's visit to the AS41. There is also room inside the AutoSound to store 4 months' worth of consumables. Vaisala AutoSound can perform soundings in various environmental conditions. The maximum operating wind speed is up to 25 meters per second, while the maximum precipitation is 50 millimeters per hour. The unit can be used in temperatures ranging from -40 degrees to +53 degrees Celsius. The unique design of the launcher vessel covers is very tolerant for snow loads, as the unit is able to operate even if there is 150 kilograms of snow on top of each cover. As the covers are opened, majority of the snow falls off and the load is lightened. The AS41 utilizes the Vaisala MW41 sounding system as the ground equipment receiving and processing the sounding data. The MW41 ensures high-quality data received reliably from Vaisala's RS41 radio sounds. The AS41 together with the MW41 can perform fully automatically, but if needed or wanted, a remote connection to the system can be established. The user can operate the system remotely through the AS41 control software user interface or the MW41 user interface, exactly the same way as being physically present in the AutoSound. The AS41 can also be equipped with 3 web cameras, allowing visual remote monitoring of the system. One camera is shooting at the robotics inside the AutoSound, one is observing the inside of the launcher vessel, showing how the balloon is filled in and released, and the third camera is outside of the system showing the liftoff of the radio sound and the balloon. These cameras enable the user to actually see what is going on in the AutoSound and also provide important information for debugging possible problems, as all the videos are stored into a network video recorder for 1 month. The operation of the AS41 is secured even during power outages. The system has an integrated UPS to ensure that the possible ongoing sounding during a power outage will be completed, or as an option a UPS with a bigger battery capacity that allows a full sounding to be made without mains power. starting from ground check of the radiosonde, filling in the balloon, releasing the sounding and completing it. The expected lifetime of an AS41 is more than 15 years when properly maintained. The AutoSonde has a preventive maintenance program with annual maintenance visits to the system. Once a year, a light check is made and some filters changed. Every 5 years, the maintenance routine is a bit more comprehensive, and every 10 years, the ICT parts, such as the PC and the UPS, need to be changed. Reliable automation, such as Vaisala Automatic Sounding Station AutoSonde AS41, provides operational cost savings with reduced labor costs, continuous autonomous operation, and safe usage of different lifting gases. It is suitable to be used in virtually any conditions, and it will provide consistent and accurate data. As more of severe weather phenomena are happening around the world all the time, the need for accurate high-quality data of the atmosphere is ever increasing. Vaisala has been developing sounding equipment for over 85 years to fulfill the need. The latest Vaisala sounding system provides this data more reliably than ever. I'm happy to introduce the Vaisala Cirrus sounding system MW51. The MW51 consists of antennas, ground check devices, and other peripherals. But at the very heart of the system are the sounding processing subsystem, the radio receiver, and the sounding software. The core items of the sounding system have been totally renewed and form the basis of the latest Vaisala sounding system. The new sounding processing subsystem, SPS 511, is developed solely for sounding purposes, with optimal performance on receiving data from the radiosondes and filtering out near-band interference. This enables better data reliability, resulting to more accurate atmospheric profile. The fully new sounding processing subsystem has been packed into a compact housing that is IP54 rated, providing good resistance against dust and even splashing water. The size, weight, and ingress protection of the SPS all play a role in making the MW51 sounding system well suitable for research campaigns and other portable use. As the MW51 utilizes the already familiar variety of Vaisala antennas and peripherals, you'll be sure to find the correct alternatives for your own use. The SPS 511 is built to last. With, for example, one integrated circuit board design and conductive cooling, the possible points of failure have been minimized. The hardware inside is state-of-the-art, and new features can be introduced to the unit with just firmware updates, without the need to upgrade the physical unit. The SPS is future-proof. The Digicora sounding software offers the user a new and intuitive user interface where the user experience is at the very core of the design. The configuration of the system is made fluent, and the software allows the administrator to pre-configure the station parameters, wide range of message formats, triggers, and destinations. The Digicora software then guides the operator through the whole sounding process, starting from sound preparation and ending to a flight summary that shows with one glance all the relevant information of the sounding. During the whole sounding, a flight plan is visible for the operator to see the status of the sounding, reached altitudes, created messages, message sending status, next configured message triggers, and so on. The trajectory of the radiosonde can be followed on a map view, and the PTU graphs and data tables show the operator the measurement data in real time. IT security of the system is maintained through regularly available security updates, both for the Digicora software and for the embedded firmware in the SPS. These updates, together with the security architecture, including features like secure boot, encrypted communication between the SPS and the computer, authentication, and many more, minimize the IT security threats that all information systems are subjected to. The Vaisala Cirrus sounding system introduces the capability to receive multiple radiosondes simultaneously, a feature that allows collecting more frequent data of the atmosphere. Next radiosonde can be released before the previous sounding or soundings have been terminated, which means that the user can receive a new vertical atmospheric profile more frequently than before. The Vaisala Cirrus sounding system MW51 is the foundation of modern meteorological upper air observations.
Thank you for your attention. This was only a snapshot of what all Vaisala is doing. Please remember, we are also the world leading supplier for lightning detection systems. We have just introduced to the market a new solid-state X-band weather radar. We supply wind shear detection systems combining wind lidars, weather radars and low-level wind alert systems. And we have also been supplying large meteorological infrastructure systems, such as the ones that we have just delivered in Bahamas, Vietnam, and currently are being delivering to Ethiopia. We at Vaisala are eager to work with you to find solutions to your needs all over the world. Looking forward to meeting you all soon.